In this video, I'm going to demonstrate the use of the force model to solve an elevator type problem that accelerates. So in this problem, I'm going to have an elevator, and in the elevator is going to be a person, and it's held up by a cable, the supporting cable. And this elevator is going to actually accelerate downwards at a rate of -2 meters per second squared. So this is a situation where you might be on the 10th floor and you hit the down button, so the acceleration will be downwards toward the first or second floor. And the question here is to find the tension in the cable right here while the acceleration is occurring. So in the force model we have three steps. We draw a free body diagram, we sum the forces, and then we solve. Normally the solve is supposed to be right here, but I'll give myself some room to write, but put solve right here and you can work down on your paper. So for the FBD, the first step of the free body diagram is to draw the object in question. So I'm going to draw the elevator and the forces acting on it. So we have one force acting up, the tension, and then the elevator and all of its contents will be the force of gravity, mg, and that's it. We don't draw displacements, velocities, accelerations. Those are the results of the forces. The forces are what cause the motion. Step 2 is we sum the forces. So I'm going to define the positive x direction like this. Make sure we do that, and the positive y direction up. Okay. Otherwise, I have my template here, and we use the template every time. Your job is to fill in the 4 boxes. So I don't see any arrows that point left or right, so we just have 0 and 0 here. Okay. So on your homework, I'm looking for the zeros there to make sure we address these 2 boxes. In the y direction, we have a couple forces. So we have a tension that points up, and we have an mg that points down. Okay. And in this problem, there's an acceleration, so it's not 0. We can cross it out. And in fact, it's a negative. So I'm going to put that negative right there. That's really important because the acceleration is down. If we're accelerating up, that'd be positive. So those are my force equations. Step 3 is to solve. So I'm going to solve for the tension in the cable. So I basically have my equation here. That's my equation. I've built an equation for this problem. So T minus mg is equal to minus MAJ. So therefore the tension is equal to mg plus mg minus ma. And now we can plug in numbers. So here's the, oh, and I didn't give you the mass of the elevator. The mass of the elevator is 1,000 kilograms. So for the tension, now this is a math problem, but there's one little detail we want to make sure we cover. The mass is 1,000, so that's easy. Now G is, from kinematics, it's negative 9.8, and it's still negative 9.8. However, the negative from the negative 9.8 is right there. So the G you see right here is the magnitude. That's 9.8, and that's the negative. If you look back at the free body diagram, that's why we drew the arrow downwards to begin with, because it's negative G. So, bottom line, when you do force problems, when you see just the variable G, it's 9.8. If it has an accompanying negative sign, its own negative sign, then you put it in. But this is just the magnitude of it. Minus 1,000 times 2. Why 2? There's a negative, there's a 2. Why do we put that negative in there from the get-go? Because we had negative acceleration. So basically, if you want to get specific, all these equations should look like this. The algebraic sign meaning the direction. So just for sanity's sake, we're not going to draw absolute values in every single thing. However, we do have to make sure that we know that these are the magnitudes and these are the directions. So it's still negative 9.8. So if you plug in the numbers here, you get what? This is 9,800 minus 2,000. So I get 7,800 newtons. And I get a positive value, which implies up, so that's good. If I get a negative, it would mean down. J, and I box my answer. So, just looking at the result, while this elevator is accelerating downwards, it's, if you want to state it like this, it's kind of taking some weight off the cable. It seems a little bit lighter. Conversely, if I were to accelerate upwards, which would put a plus sign there, and a plus sign there, and plus sign there, basically adding on extra weight, I'd get more tension. So there'd be a higher tension in the cable to accelerate upwards. But since I'm letting it fall or letting it accelerate downwards, it takes some tension off the cable and I get a lower value than if it were just the weight itself, less than 9800. So in summary, same format. We have a given, we have a find. The solution for a force problem consists of three parts. Drawing an FPD, which is the physics. If we can draw this, then we have to fill in the force equations, taking notice from negative signs. Once we do that, then we can solve. And the key point here is knowing that when you plug in 9.8 for these problems, it's the positive value because the sign is taken care of in front. So that's the basic structure of a force problem.